so now we're going to get into some problem solving exercises. We're going to apply what we just learned with respect to the metric system and see how we can use it to solve the problem of converting from one unit to another. So the process by which this is done, we call it dimensional analysis, all right? And basically what is involved in this process is that we take a value expressed in one unit, let's say unit 1, and we multiply it by what is known as a conversion factor to get to unit 2. And the conversion factor basically represents the defined relationship between the two units. All right, so let me go back to this here. So that's basically what is involved in dimensional analysis. So these are the basic steps involved. The first thing you have to do is read the problem carefully, especially if the problem is given in words. And in reading this problem, you need to determine what is known or what is the given information and what is required, in other words, what is to be solved for. And then you write that down. I would recommend that you do that, especially if you're doing this for the first time. The second step involved is that you need to, well, actually this is part of the first step. You need to also identify all the factors and units with the proper labels. Then we move on to the second step where we determine which principles are involved and which unit relationships are needed to solve this problem. Now, you may need to refer to tables, and of course I'll provide you the tables which would give you the relevant relationship between the different units. So more often than not, you need to refer to that because I would not expect you to memorize all the different relationships between the different units. And then you set up your problem in a neat and organized and logical fashion. And in doing that, you're going to make sure that the setup is such that all the unwanted units will cancel out so that by the end of the process, you're going to end up with the unit that you're working towards. You may want to look at sample examples in the text. You can look at the examples that I will be doing in this video shortly, so you can use that as your reference, all right? Then it says you're going to proceed with the necessary mathematical operations. So this is where your calculator will come into play. And of course, when you get your final answer, you need to round off your final answer to the correct number of significant figures, which means that you have to determine the numbers that are exact and the numbers that are not exact, the measured numbers. We're going to see that in the examples that we're going to look at. Okay, and then you check your answer to make sure it is reasonable. So don't just do the calculation and just follow the answer blindly, but make sure that it makes sense. You know, do you expect to get a large number as your final answer, or do you expect to get a small number? So these are the things you need to do. All right, so as an example, we're going to look at how we convert from one unit of length to another. So here is an example. Question says, how many milliliters are there in 25 meters? All right. So basically, if you remember when I said that in dimensional analysis, we start from the number expressed in the given unit, we multiply by a conversion factor which represents the relationship between the given unit and the unit you're working towards, and then that will give you the answer in the unit that you're working towards, right? Now in this particular case, we are starting off with our value expressed in meters, and we have to multiply by a conversion factor which gives you your answer in millimeters. So the conversion factor must be a fraction which expresses the relationship between the meter unit and the millimeter unit, all right? So basically, the conversion factor you're going to use here must be set up such that the meter units will cancel out, and therefore the only unit remaining will be the one that's introduced, which would be the millimeter unit. So the conversion factor must take the form of a fraction, so therefore the fraction would be like this, where the meter unit would be down here, right, and the millimeter unit will be up here, so that the meter units will cancel out, and you'll end up with your millimeter value. So what would be the numbers involved in this fraction? Well, you have to first establish the mathematical relationship between the meter unit and the millimeter unit. And we see here, which of course you should be able to find out from the tables, 1 meter is equal to 1,000 millimeters, right? So if you divide both sides by 1,000 millimeter, you're going to get a fraction like this, 1 meter over 1,000 millimeter, which would be equal to 1, right? If you divide both sides by 1 meter, then you're going to end up with this fraction, which would be also equal to 1. So therefore, there are two conversion factors that expresses the relationship between these two units. And that is true for any such relationship. For any relationship where you have one unit expressed in terms of another unit, there are two possible conversion factors, right? You have one where, in this case, 1 meter would be the numerator, and 1,000 millimeter would be the denominator, and the other way around, all right? And the one that you use as your conversion factor is dependent on the kind of conversion that you're trying to accomplish. So to answer this question, how many milliliters there are in 2.5 meters, I'm going to show you how we set it up. Let me just choose my pen color here. Okay, so as I said before, you start off with what you're given. So we're going to start off with 2.5 meters. And the question is, what would be the conversion factor you would use to multiply the 2.5 meters by? And the conversion factor, as I said before, must be such that you have meters down here and millimeters above, right? So that this meter unit will cancel with that meter unit. So here we're going to put the numbers which show you the relationship between the two units. And as we said earlier, 1,000 millimeter is equal to 1 meter. So when you do this calculation, you're going to end up with 2500 millimeters as your answer. All right. So that's basically how you do it. Now, a couple of things I want to mention here in terms of the significant figures. You'll notice here that this number here is expressed to two significant figures, right? And this number here is a defined relationship. And if you remember, we said that whenever you have a defined relationship, that means that that relationship has numbers which are basically of infinite number of significant figures, right? So therefore, this expression here represents a number which has an infinite number of significant figures. So in this case, when you multiply the 2.5 by all of this here, you're going to make sure that your final answer will be rounded off to the lowest number of significant figures, which would be 2 significant figures. And therefore, that's how you round off your final answer when you do a calculation of this type. All right? So that's basically how that is done. Now, here is another example. Let's say you're given the relationship between the inch unit. Well, you're asked to convert 16 inches to centimeters. Now, this shows you the relationship between the inch unit and the centimeter unit. 1 inch is equal to 2.54 centimeters by definition. So this relationship is a defined relationship. And let me just say something here about relationships between metric and non-metric units. What you'll find is that in almost every case where you have a conversion from metric to non-metric, the relationship between those units will be not defined, right? So therefore you have to basically work with the number of significant figures that is provided in your tables. One exception to that is the relationship between the inch unit and the centimeter unit. That is a defined relationship, and therefore the numbers involved will be exact numbers. Okay, I'm going to say more about that in our classes when we meet. But for now, let's look at this example right here. So you're converting 16.0 inches. Let me go to the pen function again. So we're starting with 16.0 inches, and our task is to find the equivalent value in centimeters. All right, so we start off with the 16.0 inches, and we have to multiply this by the conversion factor, which represents the relationship between the inch unit and the centimeter unit. And we know that 1 inch is equal to 2.54 4 centimeters. The inch units will cancel out. So what we have to do now is work out what the 16.0, so 16.0 times 2.54, and according to my calculation, this works out to be equal to 40.64 centimeters, but that's what I get on my calculator display, but I have to round off to 3 significant figures because 16.0 is expressed to 3 significant figures. This is an exact relationship. So therefore your final answer will be equal to 40.6 centimeters. And that is how we do that. Alright? So those are 2 relatively simple examples of how we convert from one unit to another. Alright? Now here's one that is slightly more complicated, because in this case you're asked to convert from, let me write it down here, 3.7 times 10 to the 3, 10 to the 3 centimeters, and you're to convert it to its equivalent value in micrometers. Alright? So how do we do that? Well, it may not be obvious to you what the relationship is between the centimeter unit and the micrometer unit. However, we know the relationship between the centimeter unit and the meter unit, right? And we can convert therefore from centimeters to meters using that relationship. We can also, after that, convert from meters to micrometers, again, based on the relationship that would be provided in the table, what micro means, 10 to the minus 6. So we can basically do this process, getting the final answer, in 2 steps, where 2 conversion factors are required. So let me rewrite the 3.7 times 10 to the 3 centimeters here, and I would multiply that to go from centimeters to meters. I'd multiply that by 100 centimeters down here as a denominator and 1 meter above as a numerator, so that the centimeter units will cancel out, right? So up to this point we're left with the meter unit, and therefore the next conversion factor is where we convert from meter to micrometer. And based on the information provided in the tables, you would see that 1 micrometer is the same thing as 10 to the minus 6 meters. Alright, and we work that out. So 3.7 times 10 to the 3 divided by 100 divided by or 10 to the minus 6, and the answer I got is 3.7, let me do it here, 3.7 times 10 to the 7 meters. Alright, and again, because this is written to 2 sig figs, and these are exact values here and here, that means that this will be expressed to 2 sig figs here, and that's how you get that. Alright, so that's the final answer, 3.7 times 10 to the 7 meters. Alright, okay, so that's how we do that. So the point here is that in some cases you may have to use more than 1 conversion factors in series in order to convert from your given value to the required value in the required units. Alright, okay, I'm going to stop here, and then the next topic we're going to discuss is measuring mass and volume. Until next time.